For the last video, for chapter 3 of the textbook, we're going to be going over a practice problem where we look at a price ceiling as well as a tax. And the market we're going to be looking at is the market for ice cream, in San Marcos. So our demand curve for this market is given by quantity demanded equal to 20 minus 2 times the price. Our supply is given by quantity supply equal to 4 times the price minus 10, all right? And our, quantity variable is just measured regularly in standard units, and price is measured in dollars. So our first part of this question is to find the equilibrium price and quantity of ice cream. To do that, we're going to set quantity demanded equal to quantity supplied. Well, 20 minus 2 times the price equal to 4 times the price minus 10. We're going to solve for the price by adding 10 to both sides. That's going to give us 30 minus 2 times the price equal to 4 times the price. Then we'll add 2 times the price to both sides. That'll give us 30 equal to 6 times the price. From there, we'll divide both sides by 6. And that's going to give us a price of $5 for each pint of ice cream. Okay. Quantity here, right? We want to check to make sure we have the correct equilibrium price. So we're going to substitute for the price in both the demand and supply equations. So we'll have quantity demanded equal to 20 minus 2 times the price of $5. That gives us 20 minus 10. So quantity demanded is 10 pints of ice cream. Quantity supplied is given by 4 times the price. Price here is $5 minus 10. That gives us also 20 minus 10. So quantity supplied is also 10. And our equilibrium quantity then is 10 pints of ice cream. Let's go ahead now and draw this market. So we have, again, the market for ice cream. Our demand equation is going to intersect, our demand curve, is going to intersect the quantity axis at 20 pints. If we substitute 0 for 20 in our demand equation and solve, we're going to get a choke price of $10. So at $10, no one is buying any ice cream. For our supply curve, we want to also find the supply choke price. So we're going to substitute 0 for quantity and solve for the price. So we're going to get 10 divided by 4, which is going to give us a choke price of $2.50. And we already found our equilibrium price is $5 and our equilibrium quantity is 10. So we have 2 points to draw our supply curve through. All right, and there is our market. Now we can move on to part B, which asks us to find the consumer and producer surplus in this market. So consumer surplus is going to be the area above the price that consumers pay and below the demand curve. So our top triangle here in blue. Producer surplus is the area below the price that sellers receive and above the supply curve. So our green triangle here. To find these, we're again just going to use the area of a triangle formula. So for consumer surplus, we'll have 1/2 times our base, which is the amount traded. So 10 minus 0 times the height, which is the difference between the choke price and the equilibrium price. So 10 minus 5. Simplifying gives us 1/2 times 10 times 5. All right, 1/2 times 10 is 5. 5 times 5 is 25. So our consumer surplus in this market is $25. Producer surplus is similarly a triangle. So we use that area of a triangle formula. So producer surplus is 1/2 times our base, which is the number of pints of ice cream sold, which is 10 minus 0, times our height, which is the difference between the equilibrium price of 5 and the supply choke price of $2.50. So we get 1/2 times 10 times $2.50, $2.50. 10 times 2.5 is going to give us 25. So we have 1/2 times 25. 1/2 of 25 is going to is going to get us 12.5. And so our producer surplus is $12.50. Now we're going to impose a market intervention of a price ceiling. So suppose the San Marcos governor imposes, mayor imposes a price ceiling set at $4, right? Cheaper ice cream for everyone is their platform. All right, so that price ceiling is set below the market price, means that it's going to bind, it will have an effect. That lower price moves sellers down along the supply curve, meaning that quantity supplied falls below the equilibrium quantity. And it moves consumers down the demand curve, meaning that quantity demanded is going to increase above that equilibrium point. So now we want to find the quantity supplied and demanded at the given imposed price of $4. So for our demand, we're just going to substitute for the price in the demand equation. So we'll have quantity demanded equal to 20 minus 2 times the price of $4. So 20 minus 8 is going to give us a quantity demanded of 12. Okay. For our quantity supplied, right, we're just going to substitute for price in the supply equation. We'll have quantity supplied equal to 4 times the price, which is 4 minus 10. So we'll have quantity supplied equal to 16 minus 10. So quantity supplied here is 6. And we can see that there is indeed a divergence between these two values. In this case, quantity demanded exceeds quantity supplied. And so we have a shortage of ice cream. Okay. Moving to D. D asks us to find the consumer and producer surplus under the price ceiling. All right. So we're going to redraw these triangles here. The price ceiling moves the price for ice cream down. And so ice cream is now cheaper than it was before. And so our consumer surplus, again, is that area above that $4 price and above the, below the demand curve. So above the $4 price and below the demand curve. So this new, much larger triangle. Oh, excuse me, I drew that incorrectly because we don't have 12 pints of ice cream traded. We only have 6. So it's going to be this trapezoid shape. Oh, my price ceiling went away for some reason, as well as my supply curve. There we go. Okay. So it's a new trapezoidal shape, whereas producer surplus is a much smaller triangle below the price that sellers receive and above the supply curve. Okay. So we need to find the area of these two. To start with consumer surplus, we want to find the price at which consumers demand only 6 pints of ice cream. So we're going to substitute for that value in our demand equation. So we will have 6 equal to 20 minus 2 times the price. Okay. And solve for that price. So we're going to add both sides 2 times the price. That gives us 2 times the price plus 6 equal to 20. Then we're going to subtract 6 from both sides. That gives us 2 times the price equal to 14. And divide both sides by 2. We get a price of $7. Okay, so we can add that, add that into our graph here. All right. And now it makes it very easy to find the area of our consumer surplus. We're just going to find the area of that top triangle and add it to the area of that bottom square. So consumer surplus here is going to equal 1/2 times the difference between the choke price, which is 10, and the price at which consumers demand 6 pints of ice cream, which is 7, times those 6 pints of ice cream squared. And to that, we're going to add the difference between the price at which consumers demand 6 pints of ice cream and the price ceiling. And we're going to multiply that by the 6 pints of ice cream sold. So simplifying gets us 1/2 times 5 times 6 plus 3 times 6. 5 times 6 is 30. So we have 1/2 times 30 plus 18. Half of 30 is 15. And add to that 18, right? That's going to get us a consumer surplus of 32. Excuse me, 33. I knew that was the one. Okay. All right. Oh, I think maybe I put the wrong choke price. Yes, I did. Okay, so let's try that again. So in our initial consumer surplus setup, our height is the difference between the demand choke price, which is 10, not 12. So we'll have 10 minus 7 times 6 minus 0 times 1/2 plus 7 minus 4 times 6 minus 0. And simplifying from here, that's going to get us 1/2 times 3 times 6 plus 3 times 6. That gets us 1/2 times 18 plus 18, which gives us 9 plus 18, which is 27. All right. That's what it's supposed to be. Okay. Now we need to find our producer surplus. And our producer surplus is just that smaller triangle. So we're going to have 1/2 times the base, which is the number of ice creams traded, which is 6, times the difference between the price ceiling of $4 and the supply choke price of $2.50. So we'll have the producer surplus is equal to 1/2 times 4 minus 2.5 times 6 minus 0. Simplifying, we get 1/2 times 1.5 times 6. 1/2 of 6 is 3, so we get 1.5 times 3, which is equal to $4.50. And then for surplus, we now want to find as well what our deadweight loss is with this price ceiling. Okay. So the deadweight loss is the foregone trades because less is traded than would be under equilibrium. So it's this pink triangle that I've drawn in here. And to find that, we're going to find the area of that triangle. So 1/2 times base times height. Our base is the difference between the amount sold in equilibrium and the amount sold under the price ceiling. And then our height is the difference between $7 and $4. Let's go ahead and do that. So deadweight loss, this is for part E of the practice problem. It's equal to 1/2 times 10 minus 6 times 7 minus 4. So we get us 1/2 times 4 times 3. So that's 2 times 3, which gives us 6. So the deadweight loss is $6. In part F, now we're going to move on to the situation where instead of placing a price ceiling on ice cream, the San Marcos mayor is going to tax ice cream instead as a way to reduce consumption. And that tax on ice cream is going to be set to $1. To start, we're going to go ahead and draw our graph again, so our previous one doesn't get too messy. All right, this is ice cream. Our supply curve starts at $2.50, and our demand curve goes to $10. Equilibrium was $5, and 10 pints of ice cream was sold. And I believe the quantity was 20 for the demand. Okay. All right. So we want to see if we put our tax wedge in here, how is that going to impact the price that sellers receive and the price that buyers pay? So the top price here is the price that buyers pay, and the bottom is the price that sellers receive, because our tax creates a wedge between the two. And we also want to find the quantity traded with the tax. In order to find the new price that buyers will pay with this tax, as well as the new price that sellers will receive, we're going to use the relationship shown by our graph here. And that's that the price that buyers pay is going to be equal to the price that sellers receive plus the size of the tax. So we know that our tax is $1. So we can go ahead and write that in. So we'll have that the price that buyers pay is equal to the price that sellers receive plus $1. And just like our subsidy example, we're going to substitute for the price that buyers pay, but this time we're going to substitute in the demand equation, right? If we were to rewrite our equations for supply and demand, we would have on the demand side that quantity demanded is equal to 20 minus 2 times the price that buyers pay. And for supply, we would have that quantity supplied is equal to 4 times the price that sellers receive, minus 10, okay? So in order to solve for that equilibrium point, we need both of those prices to be the same value. So in order to do that, we're going to substitute for the price that buyers pay in our demand equation. So we'll have quantity equal to 20 minus 2 times the price that buyers pay, which we said is equal to the price that sellers receive plus 1. And then we're just going to simplify. So we're going to distribute that -2. So we get that quantity demanded is equal to 20 minus 2 times the price that sellers receive, minus 2. And then 20 minus 2 is going to get us 18. So we'll have quantity demanded equal to 18 minus 2 times the price that sellers receive. And now that we have both supply and demand in terms of the price that sellers receive, we can solve, set quantity supplied equal to quantity demanded, and solve for that value. So we'll have quantity demanded. Oops, sorry about that. Let me straighten out this page. Quantity demanded is going to be equal to quantity supplied. So we'll have 18 minus 2 times the price that sellers receive equal to 4 times the price that sellers receive minus 10. Then we'll add 10 to both sides and add 2 times the price that sellers receive to both sides. That's going to give us 28 equal to 6 times the price that sellers receive. Then we'll divide both sides by 6. And that's going to give us a decimal that repeats. And so we're going to round to the nearest hundredth since we're dealing with currency. And so we'll get that the price that sellers receive is equal to $4.67. Again, just rounding to the nearest hundredth when we divide 28 by 6. Now that we have the price that sellers receive, we can substitute that into our relationship between the price that buyers pay and the price that sellers receive. So we find that the price that buyers pay is equal to the price that sellers receive, which we just found was $4.67, plus the tax, which is $1. And so the price that buyers pay is equal to $5.67. So they're different by $1. And so now that we have those values, we can go ahead and find how much ice cream is traded in this market. So we're going to substitute the price that sellers receive into the supply equation, and we'll substitute the price that buyers pay into the demand equation. So we'll have quantity supplied equal to 4 times the price that sellers receive, which is $4.67 minus 10. That's going to give us 18.67 minus 10, which leaves us with 8 and some change of ice cream. If we're just talking about, say, like pints of ice cream, we could actually round this so to the nearest integer. So it's just 8 pints of ice cream. On the demand side, we'll have quantity demanded equal to 20 minus 2 times the price that buyers pay, which is $5.67. Simplifying, we'll get 20 minus 11.34. And that's going to leave us with 8.67. Rounding, we're going to get that quantity demanded is 8. And so under the tax, 8 pints of ice cream are traded. Now we want to find the distribution of surplus in our market with the tax. So we're going to go back to our graph and identify all our different elements here. So consumer surplus is going to be the area above the price that buyers pay, which is that $5.67, and below the demand curve. Oops, that should be consumer surplus, not producer surplus. There we go. Producer surplus is the area below the price that sellers receive and above the supply curve. And that is, of course, $4.67. Our deadweight loss is the difference between what is traded under the tax and what is traded in equilibrium. So our pink triangle here. And we found that 8 pints are traded under the tax. And then lastly, our revenue that is generated for the government by this tax is the size of the tax. So that $1 difference between the price that buyers pay and the price that sellers receive times the number of pints of ice cream sold, in this case 8. So that purple rectangle is our tax revenue. So let's start by solving for our consumer and producer surplus. So we're just going to solve for the area of our triangle, which is drawn in blue. So we'll have 1/2 times the base, which is the number of pints of ice cream sold of 8, minus 0, times the height, which is the difference between the demand choke price and the price that buyers pay, which is $5. So writing that out in our equation, consumer surplus equal to 1/2 times 8 minus 0 times, I believe what was it, 10? Yeah, 10 minus 5.67, $5.67. That's going to give us consumer surplus equal to 1/2 times 8 times 4.67. Sorry, not 4.67, 4.33. Half of 8 is 4, so we have 4 times 4.33. And then 4.33 times 4 is going to give us $17.32. Producer surplus is going to be that bottom green triangle. So we're going to use that area of a triangle formula. So we'll have 1/2 times the base, which is the amount of ice cream traded, minus 0, times the height, which is the price that sellers receive, minus their choke price. So 4.67 minus 2.5. We'll go ahead and write that out in an equation. So we'll have producer surplus equal to 1/2 times 8 minus 0 times 4.67 minus 2.5. That's going to give us 1/2 times 8. And then 4.67 minus 2.5 is going to give us $2.17. Half of 8 is 4, so we have 4 times 2.17, and that is going to give us $8.68 for our producer surplus. Next, we want to find our deadweight loss. Deadweight loss, again, is that pink triangle. So we're just going to solve for the area of that triangle. So we'll have 1/2 times the base, which is the difference between what's traded in equilibrium and what's traded under the tax, times the size of the tax, which is $1. So we'll have deadweight loss equal to 10 minus 8 times $1. It's going to be 2 times 1. And so our deadweight loss times 1/2 times 1/2 is going to be 1/2 times 2, which is just $1. And then lastly, we're just going to solve for the government revenue here. So our revenue, again, is the area in purple. So we're just going to solve for the area of that rectangle. So we'll have length times width. Length is the amount traded under the tax. So that was 8 pints of ice cream times the width, which is the $1 tax, right? $5.67 minus $4.67, right? That wedge between the price that buyers pay and the price that sellers receive. So we have 8 times 1. That's going to give us revenue then of $8 for the government. Okay. And with that, that concludes our practice problems for this chapter. In class, we'll be doing some more of these, making a point to draw the graphs while solving the mathematical problems, so you can really see all these different areas that we're solving for. and the impact of the price interventions as well as the quotas.